Now for part C, which is Z3, part C, it says that Z3 is given as 3I minus 2. Draw your Gann diagram quickly. We carries marks. Be careful. Draw this is Z3, that is the real axis. This is the imaginary axis of Z3. Then you come, this is the origin. This should be very straight. Use a ruler. Yes. Now we have 3 and 2. In magnitude, 3 is bigger and 3 is on the imaginary axis. So 3 is there and the corresponding negative 3 is there. 2 should be closer due to the origin, and then negative 2 on this side. Now we draw a complex number. On the real axis, we need to locate negative 2, which is here. On the imaginary axis, we need to indicate positive 3, which is up here. So they are going to meet somewhere here. This one goes up straight, vertically straight, horizontally straight. So they are going to meet somewhere here. Negative 2, positive 3. Then you draw your complex number, straight line to the origin, put an arrow on top here, and say this is my Z3. After that, we need to get the argument. Always start by measuring it from the positive x-axis here, anti-clockwise up to where the complex number is. Now, what do we know already? We know already that from here to here is 90 degrees. But we are looking for the angle from here up to where the complex number is to give us the argument. Now, since we know this side is 90, what is this small section here? We don't know this small section here. What can we do? We extract the triangle from here to here and then to there. So it is looking in this format. I have dotted line up there, and then this is the dotted line, vertically straight downwards. Then I have the complex number, which is in that sense, which I'm going to draw with that. So this is where the small angle that we are looking for is. You can use any letter that you want. Any letter. Let me use A. Now you need to indicate the distances from here to here is the same as from here to here, which is 2 units. Then from here to down here is the same as 3. It is positive 3. So this is positive 3. From here, positive 3. From here to here is the same as from there to there, negative 2, which gives us 2 units, correct. Now, this is the angle we are looking for. This is where the right angle forms. For any angle that you extract, for any triangle that you extract from the complex number, it must be a right angled triangle. So this is the angle opposite to the angle we are looking for is 2. So this one forms the opposite. This is the adjacent, and the longest side is always the hypotenuse. Applying SOHCAHTOA, if we are applying sine, we need hypotenuse, which is not there. Of course, we need hypotenuse, which is not there. So let us just go with tan, because we have the opposite and the adjacent. If you want to use sine or cosine, you must first find the hypotenuse. And after getting the hypotenuse, and then you calculate the angle, we shall get the same answers, whether you use sine, cos, or tan. So let us not waste time, let's use tan, so that we use the given values. So we're going to say tan of the given angle, which we are saying A, is opposite out of adjacent. That means we need to substitute. So tan of angle A is equal to, what is the opposite? Opposite is 2, adjacent is 3. That means that for us to get the angle A, we need to get the arctan or tan inverse of 2 out of 3. Then you get your calculator and say tan inverse of 2 divided by 3, 33.69. It gives us here 33. 33.69 degrees. That means this small angle is 33.69 and it is this small angle we are calling here 33.69. Therefore, the argument, which is theta, that's what the argument. So now the argument theta is going to be equal to this 90 here plus the other small part of the angle which we have obtained as 33.69. So plus 90, 120 something. This gives us here 123.69 degrees. That is the argument. Then you come and judge the argument. Is it in this range of negative 180 to 180 degrees? Yes. Yes, it is in that range. If it is in that range, then we say it is the principal argument. So the argument is the principal argument. We are calling it the principal argument because it is lying in that range. So the principal argument, we are going to say arc of Z3 equals to 123.69 degrees. This means that for it to just be called argument, remember, this is also argument. The principal part says that it is in this range, but whether it is in that range or it is not in that range, it is first called argument. The term argument is used for the angle, whether the angle is within this range or outside that range. But the moment it falls in that range, it is called principal argument. So argument is a bigger name that accommodates both the values that fall in this range and those that fall outside that range. But I'm going to repeat, we cannot punish any student that has been asked to find the principal argument and find only the argument. Even if it is outside that range,